2/7, tomorrow's 2/8. Thursday will be a review day. The chapter test I broke into 2 days. So we're going to take, I believe, the Schoology part on Friday and then the written part next Monday. So they'll be split over the weekend, but you're going to take half of it Friday, the other half Monday. Okay. So section 2/7, we are solving equations in one variable. I'm going to make sure I'm not muted. I don't believe I am. Perfect. And here are our notes for today. We are working with today rational equations. A rational equation just means that we are going to have fractions, and more specifically, we're going to have fractions that also will tend to have variables in the denominator. So that just means that we've got fractions with variables in the denominator. When you have variables in the denominator, you have to be careful and you have to look out for these things called extraneous solutions. An extraneous solution is, I'll give you a math definition as well, but an extraneous solution is just an extra solution or an extra answer that you will solve and you will have done everything perfect. But when you check it back in the original problem, it gives you an error. So it's just an extra answer that causes an error in the original problem. Now you might say, well, how does that happen? Most of these, if not all of these problems, what we are going to do, our goal is going to be actually get rid of the fractions. And by getting rid of the fractions, you're turning it into another type of equation, maybe a quadratic, maybe a linear, but an equation that we can solve. And sometimes we'll get answers out of those quadratics that won't work in the original problem. So if I look at example 1, I can tell you the one number that cannot work for the example 1. What's the one number that I cannot have x equal because of that fraction? 0. So if I solve and I do everything right and I happen to get x equals 0 as one of my answers, I just have to cross it off and say, no, this must be an extraneous solution. It doesn't mean I will get that, but if I do, I need to know that I can't have that 0 in the denominator. Okay, so when I start these, I actually check for that. I'm like, what can't I have? I can't have 0, so if I get that, I'll have to cross it off. To solve this one, x plus 3 over x equals 4, I'm going to get rid of the fractions. So right now I'm technically dividing by x. So what I'm going to do is I'm going to multiply, but I have to multiply everything by x. So I'm going to, whatever I do to one side, I also have to do the other side. On this left-hand side here, x times x will give me x squared. And here's the whole reason why I'm multiplying by x. If I take x times 3 over x, that would be like 3x over x. And the x's completely cancel, and all I have left is a 3. So I'm just going to say plus 3 equals 4x. If you multiply, like we are right here, by the same thing that you're dividing by, they're going to undo each other and they're going to cancel out. So you don't have to show this work that I just did over here every single time. You can say, well, I'm multiplying by the same thing that I'm dividing. Those quantities cancel, and I just have that 3. I'm now left with a quadratic. We can solve quadratics. Normally when we solve quadratics, we set them equal to 0. And we're either going to use quadratic formula or try to factor. I believe that this one will factor for us, so I'm going to just try to factor. So the only way to split up x squared would be x and x. I can split that 3 into, since I need it to be a negative 4x here, a minus 3 and a minus 1. Because the negative times the negative would be positive. I'm not done yet. I actually have to solve. So I'm going to set each piece equal to 0. When I do that, I get x equals 3, and I get x equals 1. If you didn't think to check at the beginning what's the one number we can't get when we said 0, then at this point, I would just check, would this one work if I put it right here. You don't even have to evaluate to see if there's equal. They should be equal. Basically, I'm just saying, will I get an error? Nope, I can take 3 divided by 3 and it works out. So I'd say, yeah, that first one works. And then I'm going to do the same thing with this. If I put a 1 here, yes, I can take 3 divided by 1. So I don't have to worry about that. So both of those are my answers. I don't have any extraneous solutions. So in this case, I've got 2 answers, 3 and positive 1. Okay. Then we're going to start to make it a little bit more complicated. Instead of just having an x in the denominator, I'm going to have a quantity in the denominator. But I'm going to try to do the same thing that we just did. I'm going to try to get rid of any fractions. Once I've gotten rid of any fractions, I'll have a new equation that doesn't have fractions, and then I can hopefully solve. And that last one, I multiplied everything by whatever the denominator was. So I multiplied everything by x minus 4. Here, I multiplied everything by x. Here, I'll multiply everything by the quantity x minus 4. Whatever I do to one side, I also have to do to the other side. I'm going to write this first step out just so that you don't miss anything. So I'm going to take this quantity times x, and I'm just going to write it like this. That quantity is being multiplied by x. And I'm going to take that quantity times this fraction. And then on the right-hand side, I'm going to take that quantity times 0, but I know anything times 0 is 0. Here's where that gets me. I need to distribute out that x to both terms there. That'll give me x squared minus 4x. Here, kind of like that last one where the x's canceled out, I can say a quantity x minus 4 is going to cancel with the quantity x minus 4 because I'm multiplying by the same thing that I'm dividing by. And multiplying and dividing cancel out. Or you can think of this as like it's the fraction x minus 4 over 1, and then those quantities cancel out. All that I have left between all of that is that 1. And then I want to try to solve this. Now, this one won't factor for me because the only numbers that multiply to 1 are 1 times 1. Doesn't mean it's not possible. It just means that it's not a nice rational number, which means I have to use quadratic formula to try to finish solving. So I'm going to use quadratic formula, and I'm going to say x equals the opposite of b plus or minus the square root of b squared. Negative 4 squared would be 16 minus 4 times a times c all over 2a. And then I'm going to just try to simplify that and give myself a lot of space. So I'm going to write it here. 16 minus 4 would be 12. At this point, you can either write your answer in simplest radical form, or you can write it in decimal form. I don't have one method that I prefer over the other. If I'm writing it in simplest radical form, you'd have to reduce that root 12. Remember when you reduce square roots before, that'd be like root 4 times root 3, which would really be 2 root 3. So if I was trying my best to keep this in simplest radical form, I would have that. And then I could divide each term by 2. So that would give me a 2 plus or minus the square root of 3. And I'd say perfect. If you are looking at that and you're like, yep, I mess that up all the time, I don't want to have to do that, that's just fine too. Then you're just going to say 4 plus the square root of 12. Did I mess up? See, square root 12. Divided by 2. One of my answers could be 3.73. And 4 minus the square root of 12 divided by 2, and I get 0.27. And we get that. And as you notice, if I would have done 2 plus root 3, there's that 3.73. If I do 2 minus the square root of 3, there's that 0.27, so we get the exact same thing. They are equivalent. When I check back to the original, what's the one number that we can't have in this original? 4. Neither of those are 4, so both of those would work. Okay. Let's keep making them a little bit more complicated as we go. So here's our next one. This one looks really complicated because now every single term has a denominator, and every single denominator is somewhat different. So I've got a 2x over the quantity x minus 1. I've got a 1 over x minus 3. And I have 2 over x squared minus 4x plus 3. Okay. When they have ones, specifically, I would say 99% of the time for this class, it's going to happen nicely like this. When they have one of your denominators as a quadratic, so the denominator on the right over here is a quadratic, try to factor that denominator. Just write it another way is what factoring really is. If I were to factor that denominator, I would say x minus 3, x minus 1. Because negative 3 times negative 1 is positive 3, and negative 1 plus negative 3 is negative 4. And then it should hopefully match what your other two denominators are. So instead of multiplying by every single denominator, we can multiply by what's called the least common denominator. My least common denominator is going to be two quantities. It's going to be an x minus 3 and an x minus 1. So I have to multiply everything on this side by two things, an x minus 3 and an x minus 1. And I have to multiply everything on this side by two quantities, an x minus 3 and an x minus 1. Now here's the good news when I do this. By doing that, we should cancel out every single denominator. When I take this quantity times this first term right here, I am multiplying by an x minus 1, but I'm also dividing by an x minus 1, which means that for this first term, the x minus 1 quantities will cancel. They're gone. But I still have that x minus 3 has to be multiplied by that 2x. Then I'm going to multiply it times this next fraction, which similar but different. In the second one, I am multiplying by an x minus 3, but at the same time, I'm dividing by an x minus 3. So when you multiply and divide by the same quantities, they cancel. The x minus 3's will cancel, but I still have to take that x minus 1 times its numerator of 1. And then the best news yet is on the right-hand side, I'm multiplying by an x minus 3, but I'm dividing by an x minus 3. I'm multiplying by an x minus 1, but I'm dividing by an x minus 1, which means both of those cancel, which means all of that cancels. And all I have left is that 2. So by doing that step, which is kind of a wicked step, and there's lots of places where you could make a little tiny mistake, by doing that, I've gotten rid of all my fractions. And now it should be a problem that we can solve. So I'm going to here, it's kind of backwards distribute, but I'm going to distribute out that 2x. That would give me 2x squared minus 6x. Technically, I'm going to distribute out that 1. All that equals 2. I see I end up with a quadratic. Quadratics we solve by setting equal to 0. So I'm going to move this 2 over and combine like terms. So I've got 2x squared, looks like minus 5x minus 3 equals 0. I believe that this one will actually factor for us, so I'm going to try and factor. If you want to use quadratic formula, you may. The only way to split up 2x squared would be 2x and x. I need one of them to be negative because I've got that negative 3. I believe I want it this way because that's going to give me negative 6 plus 1. Yeah, that's negative 5. And then I can set each piece equal to 0 and solve. When I solve this first piece, I'm running out of space, so I'm not going to show every step. I get a 2x equals a negative 1, divide both sides by 2, and I get x equals a negative 1/2. And when I solve this next one, I'm going to add 3 to both sides, and I get x equals 3. Now, here's the last check. Go back to your original. If I put a negative 1/2 Negative 1/2 would work in this first fraction. Negative 1/2 would work here. I can take negative 1/2 minus 3. And you might not want to put it into this part, but you could look here. If it works in the other two, then it should work here as well. So negative 1/2 absolutely works. If I check 3, 3 minus 1 would be 2. However, 3 minus 3 would be 0. Can I divide by 0? No. So it doesn't mean we did anything wrong. It just means that we're going to go like this and cross it off. On Schoology, if you're taking a quiz or a test and they ask you a question like this, even though we found it, that right there is considered an extraneous solution. On Schoology, the only answer I would want you to provide is negative 1/2. That is the only number that works in this problem. On the homework assignment, when you are checking your work, as well as if you check in the back of the book, they actually say x equals 3 extraneous solution. You do not need to tell me it's extraneous. I want you to actually cross it off and say, don't count this one, okay? But I wrote it on the homework so that if you were checking your work, you would recognize that, oh, I have to remember to cross this one off and say it's extraneous. Okay, so just know you don't need to even tell me extraneous. The only answer to this problem is x equals negative 1/2. Okay, let me look example 4, 2, yeah. 2 more examples and we're done. So one more like this and then a word problem. So we have x minus 3 over x plus 3 over x plus 2 plus 6 over the quantity x squared plus 2x. So once again, I've got 3 separate fractions, 3 separate denominators. Once you have that written down, look at, before I even start to multiply by anything, look at that quadratic denominator, the x squared plus 2x one. Factor it. Factor it by GCF. So see if you can factor that last denominator. If I factor that last one, you should hopefully say, well, they both have an x in common. So I'm going to take out an x. It would be x and x minus 2, which is beautiful because what do you know? That's exactly what our other two denominators are. So when I do this one, I'm going to multiply everything on this side by an x and an x plus 2. And technically, I'm multiplying everything on this side by an x and an x plus 2, but that's going to be times 0, so I really don't have to worry about that right-hand side. When I start to multiply this out, I want this entire quantity times this first fraction, times this second fraction, and times that third fraction. When I take that entire quantity times that first fraction, I see I'm dividing by x right here, but I'm also multiplying by x right here. And when you divide by the same thing that you're multiplying by, they cancel. So what I'll have left is the quantity x plus 2 needs to still be multiplied by the numerator, which is an x minus 3. Then I'm going to put a plus sign because now I need to go to my next term. So then when I take an x and an x plus 2, I see that I am dividing by an x plus 2, but I'm multiplying by an x plus 2. So the x plus 2's will cancel, and what I will have left is the x up front here times that 3. And then finally, I have to take the x and x plus 2 times that last term. Good news, I'm dividing by an x and an x plus 2. I'm multiplying by an x and an x plus 2, which means all of that will cancel with all of that denominator, and all I'll have left is that 6. On the right-hand side, it's 0 times all of that, so the right-hand side is still at 0. This one, I am going to have to FOIL that out. So I'm going to go ahead and FOIL out this. Once I FOIL that out, I'm going to combine like terms and see what I can do to solve. So when I FOIL, I get x squared minus 3x plus 2x minus 6. But then here I've got a 3x and a plus 6. If I combine like terms, I've got an x squared. Those cancel. Plus 2x. And those cancel. At this point right here, you might notice something, but an equal chance that you didn't notice something. So if you don't notice what I'm talking about, that's okay. I'm going to keep solving. You could do quadratic formula, or you could try to factor this. This one would have to be a factor by GCF. They both have an x in common. When I solve, I put this first piece equal to 0, and I set the second piece equal to 0. This one is just x equals 0. This one would be x equals -2. And then I have to go back and check. Can I have x equals 0 as a solution? Nope, because I'm dividing by x, so that one's extraneous. Can I have x equals -2? Nope, so that one's extraneous. If everything is extraneous, it's not that we did all that work to say there's no answer. The answer is that there is no answer. There's no solution to this problem, meaning there is never a time when those fractions added together will ever equal 0. Okay, so sometimes our answer is that there is no answer. But we've shown algebraically why that is. Okay, the last question, I think there's one like this in your homework, and that's why I wanted to go over this word problem. We're going to actually use, if I remember correctly, our calculator to help us solve, so I wanted to talk about how we use our calculator for some of these. But it says, find the dimensions of the rectangle with minimum perimeter if its area is 200 square meters, and find this least perimeter. A lot of times people will read this problem, and they'll say, I don't think you gave me enough information. It feels like it's very limited information, but we can use our knowledge of rectangles and how to find area of rectangles and how to find perimeter of rectangles to actually have us have enough information. Okay? So as you're writing that down, here's what I'm thinking. I'm thinking, okay, we're talking about a rectangle. In general, what I know about rectangles, besides that they have all 90-degree angles, I know that the opposite sides are equal. I don't know what my side lengths are, so I'm just going to call this side x and this side another variable y. You could use base and height, you could use length and width, whatever you want to use, but I just need something to represent the sides. I know in the end, I want to find the perimeter. How do you find perimeter of a rectangle? What do we have to do? Add up all the sides. So my perimeter equation, which now people are like, oh my goodness, you're giving us another variable. I am P for perimeter. Would be x plus y plus x plus y, or I could say would be 2x plus 2y. They also said the area is going to be 200 square meters. So I can write an area equation. Area is 200. To find area, I take length times width or base times height, whatever you want to say. I've got that. What I'm going to do is I'm going to solve this equation right here for either x or y. I don't care. I'm going to solve for one of them. So I'm going to solve for y. That gives me that y equals 200 over x. And I'm going to take that knowledge back up to my perimeter equation, replace y so that at least my perimeter equation, instead of being 3 separate variables, will now just be written in terms of 2 separate variables. So my perimeter equation should be 2x plus 2 times the quantity 200 over x. Now, I told you we're going to use our calculator, so we absolutely are. You don't have to even simplify that because we're going to make our calculator do it. But if you were to simplify that, be careful. Remember this 2 times 200 over x actually would be like a 2 over 1. So you would only multiply the tops. So we can use that equation that I have there. Or if you wanted to, just in case you were trying to do this, you only multiply the top. Some people multiply the top and the bottom, and then it doesn't work. So when it's written like this, we only multiply the top. Okay, so I'm going to go to my calculator. And I'm going to try and graph this equation. So I'm going to graph 2x plus 2 times 200 over x. I know I'm going to have to adjust my window. So we'll adjust that in just a second. So I've got that on there. I'm going to go to window. And here's what I'm thinking. The X is talking about possible lengths of this rectangle. Well, if it truly could go over an area of 200 and it's X times Y, I guess I could have the length be all the way out to 200, and then the height would have to be 1, because 200 times 1 would give me 200. I probably don't need any negatives because I can't have a negative length. So if you wanted to change that to a 0 to 200, great. My Y values then are talking about my perimeter. So if it truly was 200 long and 1 tall, that would be 200 plus 1 plus 200 plus 1, that would be 402. I'm just going to say have my Y values go to at least 400. Now, I will tell you right now, this is more of a window than we need, but it is going to work for us for this problem. Then I'm going to hit graph, like the Nike swish. They asked us to find the minimum perimeter. When you look at that part of the graph, is there an obvious minimum somewhere on that graph? That's all that we're looking for, that obvious minimum. So I'm going to go second, calculate minimum. I have to scroll for a ways because it puts it in the middle of my picture. And go to the left, go somewhere to the right, hit enter. Again, it's going to give me 2 values. Tells me my X is about 14.14. I'm looking up here, this is in square meters. The Y value of that was actually our perimeter. So my perimeter would be 56.57 if I estimate that. So they're saying, find the dimensions of the rectangle. So I have to find my dimensions and then find this least perimeter. Here's my least perimeter. The one thing I have left is this. If this is 14.14, I just have to figure out what this one is. I can do that quite easily right here. Using that Y equals 200 over X. So I'm going to quit out of there and say 200 divided by that 14.14. And what do you know, it's 14.14, which tells me that it ends up being a square that we had here. Squares are rectangles. But just know that on the word problems that might seem like they don't necessarily give you enough information, read through it and see what formulas they're trying to hint at and see if you can write something in terms of those formulas. Okay. I believe that is everything. So I'm going to end this recording.